Okay, class, section 5.4 talks about a general strategy for factoring polynomials. So we've learned a lot of different steps. We learned to factor by grouping, we learned some shortcuts, and this is where I want to talk about a general factoring strategy when you're presented with a polynomial. So the first thing you're always want to do is factor out the greatest common factor. Then figure out how many terms there are in your polynomial. If it's a binomial, it could be a difference of squares. If it's a binomial, it could be a sum of two cubes or a difference of two cubes. If it's not, then you're fully factored. If there are three terms, you could find the factors of AB that add AC that add up to B, or use one of these shortcuts, which I don't really recommend. I just don't. If there are four more terms, you're going to need to factor by grouping. Then you need to double check to make sure no factors can be factored further. If so, you need to go back through and factor completely. So let's take a look at a couple of examples. I'm trying to find my notes, but my cat is sitting on my homework. There we go. Okay, so first example we have is 9p plus 45. This is definitely a binomial. It's got two terms, okay? So the only thing I can do here, because it isn't a square and it isn't a cube, is I'm going to factor out the greatest common factor. So the greatest common factor of 9 and 45 is going to be 9, because 9 times 5 is 45. So if I pull out a factor of 9, that leaves me with 9 times p plus 9 times 5 gives me 45. So here I'm fully factored. I've got 9 times p plus 5. Our next example, I have 8x squared, y squared, plus 4xy. So I need to figure out what the greatest common factor is. I'm going to do that over here. And the way I like to do that is go by the constant, then each variable. So the greatest common factor of 8 and 4 is going to be 4. The greatest common factor of x squared and x is going to be a single x. And the greatest common factor of y squared and y is going to be a single y. So here I have my greatest common factor is 4x plus y. I need to pull out that term. So that leaves me 4xy. And I need to know 4xy times what gets me back to 8xy squared. 4 times what gives me 8? 2. X times what gives me x squared? X. Y times what gives me y squared? Y. Then I have to know what do I multiply 4xy by to get back to 4xy. And that's just going to be 1. So I check my binomial. I see it can't be factored any further. All I was able to do was pull out the greatest common factor. Next, I have 5x times a plus b minus y times a plus b. Okay? I can rewrite this by collecting the greatest common factors of these two as 5x minus y times a plus b. Okay, that's one of our precursor steps when we're factoring by grouping. So let's work through another example. I have 16x squared minus 9y squared. Okay, this is a difference of two squares. So I know if I have a squared minus b squared, that's going to equal a plus b times a minus b. In this case, my a is 16x squared. 16 is 4 squared. X squared is x squared. And b is 9. 9 squared is 3. Sorry, 3 squared is 9. And then y squared is y squared. Y squared is y squared. Okay, so now we go ahead and substitute. I know this is going to be 4x plus 3y times 4x minus 3y. And if I'm going too quickly through any of these, feel free to go back and watch the videos for sections 5.2 and 5.3. They go through a slower breakdown of how to factor these types of problems. Next, I have 8x cubed minus 27. This is a difference of cubes. And if I have a difference of cubes, that's going to factor, it's supposed to be an a, into a minus b times a squared minus ab plus b squared. So this is an example where we just determine what our a is going to be and our b, and then we would substitute in. A in this case, I'm looking for something cubed. That would get me to 8x cubed. 8 is 2 cubed. X cubed is x cubed. Okay? B in this case, 27, that's going to be 3 cubed. So I can plug into here. I've got 2x minus 3 times 2x squared, that'll be 4x squared, minus 2x times 3, that's 6x, plus b, sorry, this has to be a plus. The rule for this is if this is a minus, then this one's a plus 6x plus 3 squared, which is 9. Now I have x squared plus 10x plus 25. So I want to find the factors of AC that add up to b. AC in this case is 1 times 25. That gives me 25. So what are some factors of 25 that add up to 10? How about 5 and 5? So I'm going to go ahead and not use our shortcut and work this out fully. So what I want to do is I want to rewrite this middle term using the factors I've found. So I have x squared plus 5x plus 5x plus 25. And then my next step is to factor by grouping. So we put in some grouping symbols here. The greatest common factor of x squared and 5x is going to be a x. The greatest common factor of 5x and 25 is going to be a 5. I know I've factored correctly because these are the same. So I collect my greatest common factors and I'm left with x plus 5 times x plus 5. Oh, look, these are the same. I can rewrite this as x plus 5 squared. Okay, let's take another example. I have 2x squared minus x minus 6. I need to find the factors of AC that add up to b, and I'm going to factor this by pulling apart the middle term. So AC in this case is 2 times negative 6, which is negative 12, and b is negative 1. So what are some factors of negative 12 that add up to b? I could take a look at negative 4 times 3. Negative 4 times 3 is negative 12, and negative 4 plus 3 leaves us with a negative 1. So we're going to rewrite this middle term using these factors. 2x squared minus 4x plus 3x minus 6. And then I factor by grouping. The greatest common factor of 2x squared and negative 4x is going to be a 2x. The greatest common factor of 3x and negative 6 is going to be a positive 3. I know I've done this step correctly because these two terms are the same. I collect my greatest common factors, and I multiply them by x minus 2. It's important to note, you can always check your answer by refoiling this out or multiplying your answer out. I'm going to skip this example for the time being. No, I'm not. Here's why we need to take a look at this example. This example is 28x squared plus 6x minus 10. The first thing I need to do is factor out the greatest common factor. All of these are even numbers. The greatest common factor of these two numbers is going to be 2. So I can factor out a 2. So that leaves me with 14x squared plus 6x, nope, not 6x, 3x minus 5. So now I can factor this, and I need to know, okay, what are the factors of AC that add up to B? And my cat is sitting on my notes. Bobby, what are you doing? So AC equals 14 times negative 5, which is negative 70, and B is 3. So I need to know what are some factors of negative 70 that add up to 3. How about negative 7 times 10? So even though that was a big number, it was pretty easy to figure out what our factors were. So now I can factor by grouping, by rewriting this middle term as negative 7x plus 10x. So I have 14x squared minus 7x plus 10x minus 5. And now we factor by grouping. Not forgetting this original 2 I once pulled out as the greatest common factor. We have to keep that in there. So I have 2 times the greatest common factor of 14x squared, and negative 7x is going to be a 7x. That leaves me with 2x minus 1. And then the greatest common factor of 10x and a negative 5, that's going to be a 5, which leaves me with 2x minus 1. Okay, I then don't forget my greatest common factor I originally factored out, but then I collect the greatest common factors from our factoring by grouping. So I have 7x plus 5, and then what they had in common, 2x minus 1. Now this trinomial is fully factored. All right, this next example has 4 terms. I'm going to go ahead and factor by grouping. So we put our grouping symbols around. The greatest common factor of xy squared and y cubed is going to be a y squared. The greatest common factor of x cubed and a negative x squared y is going to be an x squared times x minus y. That gives me y squared plus x squared, which is the sum of 2 squares, so it cannot be factored anymore, times x minus y. So that is how we would factor this example by grouping.